In today's lecture, we'll talk about resource management in cloud computing. So in cloud computing environment, there are two actors which play an important role. One is the cloud provider and the other is the cloud user. Both have different objectives. Provider wants to earn as much revenue as possible with lowest possible investment, and they want to maximize the utilization of their resources, whereas users they want to execute workloads with minimum cost and execution time. So users objective is to maximize performance. They want to minimize the finishing time because they are paying as per use go model, and so they may be paying per hour for a particular service, and their ultimate aim is to minimize the cost. For cloud provider, on the other hand, they want to maximize their revenue, and they also want to maximize the resource utilization. Maximizing resource utilization is important for cloud provider because they don't want to over provision the resources to serve a particular user's demand, because they want to accommodate or serve maximum number of users in a given resource. So what happens in a cloud computing? User requests for the resources, and the cloud provider will allocate these to the user for utilization. These resources are or can be the CPU, storage, network, power. Power is an indirect resource. So we call power also as a resource, as an indirect resource, because it costs a lot to the provider to power the data centers and for the cooling. So it's an indirect resource. So basically, how to allocate these resources is broadly called as resource management. So resource management is a process of allocating these resources to meet the performance objectives. So if you look at the figure here, the workload details are gathered through Cloud Workload Management Portal. Cloud workload is an abstraction of work of that instance or set of instances that are going to be executed. So it is those demands which have to be executed at a given instance of time on the cloud. The number of cloud workload submitted by the cloud user is processed in a queue. Then based on the details which are given by the cloud user, the resources will be assigned for their execution. Now if you see, we have two main blocks in the workload management system. We have resource provisioner and we have a resource scheduler. What does this resource provisioner do? A resource provisioner will provide the demanded resources to the workload for their execution, if and only if required resources are available in this resource pool. If the resources are not available as per the requirement, or we say quality of service requirements of the user, then workload management system will ask to resubmit the workload with new QoS, which does not violate SLA. SLA is service level agreement. So service level agreement is a contract between the cloud provider and the user of certain level of service which has to be maintained throughout the execution. After successful provisioning of the resources, workloads are submitted to the resource scheduler. Now, resource scheduler will ask to submit the workload for provisioned resources. Then resource scheduler will send back the result to workload management system. And cloud workload contains the resource information. This policy selector will select the appropriate scheduling policy which is based on the workload details described by the cloud user. And then based on the scheduling policy, the resources will be allocated to the cloud workload. So basically the resource scheduler schedules the incoming cloud workload based on the workload details. So it will get all the workload details to schedule, and it will find the appropriate and the available resources and the cloud workload is mapped effectively based on that scheduling policy. So let us reiterate these steps. So cloud user submits the request for workload execution in form of workload details. So broker, a resource provisioner, is also called as broker. So what will it do? It will find the suitable resources for a given workload and determines the feasibility of provisioning based on quality of service requirements. What else resource provisioner does is that it releases extra resources, it gives back extra resources back to the resource pool. It also contains the information of the provisioned resources, and it also monitors the performance to add or remove the resources. Resource monitoring is also a very important task. And so basically, when the resources have been decided and selected for a particular workload, and then they have been assigned, allocated to a particular workload, the workload has been scheduled. So once the workload is being executed, then also it has to be monitored that whether the the QoS guarantees which have been promised to the users is being maintained or not. So quality of service parameters like availability, network, etc. So these, now if they are not being honored while the execution of the workload is being done, then what has to be done is maybe certain more resources need to be added, or certain resources may have to be removed and some other may have to be added. So all this comes under resource monitoring. So we'll look into this in more detail in the later part of the lecture. Then broker sends the request to the resource scheduler for scheduling after successful provisioning of the resources. So once the first stage is resource provisioning, and the second stage is resource scheduling. So all the provisioned resource are kept in resource queue while other remaining resources are in resource pool. So whatever resources have been provisioned for the given workload will be kept in a resource queue. The rest of the resource, they remain in the resource pool. So submitted workloads are processed in workload queue. In this stage, scheduling agent maps the provisioned resources to the given workload, executing the workload and releasing the resources back to the resource pool after successful completion of workload. So let us understand this. So resources have been provisioned for a given workload. Now the provision resources are moved to the resource queue. Now what will scheduler do? Scheduler maps the resources to the given workload, and then it executes the given workload and releases the resources back to the resource pool after the workload is complete. So one important point is that based on the quality of service requirements, scheduling of the resources for adequate workload is a challenging issue. We'll look into this in end of the lecture, that is QoS based resource provisioning, where while provisioning the resources, the quality of service required by a particular workload is considered or is taken into account. So let us formally define what is resource provisioning. Resource provisioning is to identify adequate virtualized resources for a given workload based on QoS requirement described by the cloud user. So basically it means detection and selection of resources for the given workload such that the quality of service guarantees which has been promised to the users is maintained. So cloud provider accepts the user request for resources and creates appropriate number of virtual machines and allocates them to user as per the demand. Resource provisioning is also responsible to meet users' need based on QoS and SLA negotiation and match the resources to the workload. So next, let us see what is resource scheduling. So resource scheduling is mapping and execution of the workload based on the selected resources through resource provisioning. So let us see what is the ultimate objective of resource provisioning along with coupled with resource scheduling. It is to provision the virtual machines to user without violating SLA and to fulfill the user's demand. So let us first see that what is the objective of resource provisioning. So it is distributing the workload on resources and increasing their resource consumption but reducing the time of workload execution. Let us see the steps. It is to detect and select the best resources for the user based upon their request. So the resources selected have to be optimal because there should not be over provisioning of resources to serve a user's demand, because that would not meet the objectives of the cloud provider. Resources need to serve the user should be minimum to maintain desirable level of service quality, minimum execution time and maximum throughput. Minimum execution time, the amount of resources, more resources are allocated, lesser will be the execution time. But to then maximize the throughput, more number of users need to be served with the same amount of resources in a given amount of resources. So they are contradictory requirements. That is why there has to be an optimal amount of resources which have to be allocated for a given workload at that particular instance. So what is achieved is a user gets the service in minimum cost and time, while the service provider gets the maximum profit without affecting the violation of service level agreement. Let us see the resource provisioning techniques. There are broadly three major resource provisioning techniques. First is on-demand provisioning, second is advanced reservation, third is spot instances. So on-demand provisioning is to provision the resources to the user on demand, that is at that point of time. In advanced reservation, the resources for a particular workload have to be reserved in advance. Spot instances is like giving the resources to the user if they are available at that point of time. But this is costlier than these two techniques. So let us understand these in detail. So on-demand resource provisioning. So it provides resources quickly to the urgent workloads. However, executing if on-demand resource provisioning. So in this, the demand is provided on demand to the urgent workload. But then what can happen is that if too many demands are allocated or are executed on the same resource, it will cause problem of interference and would also degrade the performance. So in this, users will pay based on the amount of resources being used. If the demand exceeds the reserved value, then additional resources are provisioned. But generally, these additional resources which are given to the user will be given at a higher cost. Let us look at the second technique, which is advanced reservation. In this, user has to reserve the resources in advance for a specific time. So this provisioning technique is used in federated cloud as well as Amazon's Elastic Cloud Compute service. So this is called as EC2, Elastic Cloud Compute. It is a service which is provided by Amazon Web Service. We'll look into this in detail later. So what is a federated cloud? Federated means union. So in a federated cloud, many cloud providers are brought together so that they serve user demands together. So in this, when there is a demand from a user side, it is not that user will be completely fulfilled by the resources provided by a single cloud provider. It might be possible that it is taking the resources from many such cloud providers, but all the cloud providers, they have been brought under a single umbrella. So this is called as a federated cloud. So in such a cloud where there are different cloud providers, advanced reservation technique is used so that the resources because they are with different cloud providers, they are reserved in advance. However, it has some drawbacks. That prediction of the future demand is required. That is, it is to be known that to serve a particular workload, how much resources would be required. And then price of the cloud resource is is a challenging issue because it keeps on varying. It might not be same, it may change. What is the problem with this particular technique? It is either over provisioning, that is allocating more than necessary resources to serve a particular demand, or under provisioning, that is the amount of resources to execute a particular workload which has been assigned is less than what was required to maintain the service level, uh, to maintain the quality of service and not violate the service level agreement. Finally, the third resource provisioning technique is spot instances. So, what happens in this is it allows the customer to bid on unused resources at a much lower cost. So, major cloud service providers, all of them, Amazon Web Service, Google, Azure, they all provide environment to use this scheme. So, in this, the resource price rate may vary very frequently based on supply and demand. So we have seen three resource provisioning techniques: on-demand resource provisioning, advanced reservation, and spot instances. Next, let us look at resource scheduling. So scheduling is a way to determine which activity should be performed based upon the required QoS. So it comprises of two functions. One is resource allocation, that is appropriate amount of resources have to be allocated to a workload so that it can be executed effectively. These the amount of resources should be minimum for a given workload. That is important for from cloud providers point of view, and desirable quality of service has to be maintained. This is required from users point of view. The next is resource mapping, that is mapping of workload to appropriate resources based on QoS requirement, um, as specified by the user in terms of SLA to minimize cost and execution time and to maximize the profit. Okay, so next is that scheduling algorithms can be broadly classified into static or dynamic. So in static, the scheduling algorithm, they need the information about the task and the resources in advance. So they need to know that how much resources a particular workload will require to be executed. So static algorithms work well when the variation in the workload is very less and the behavior of the system is not changing frequently, which is not the case in cloud computing. So thus static algorithms are not a suitable choice for cloud computing. Though they are very easy to implement, but they do not optimize the QoS parameters. So in static resource scheduling, the scene would be something like this: that the scheduler would have the information that how much resource each workload will require, and it will keep aside that much resource for that particular workload. But it does not happen like that in cloud computing. It's a very dynamic scenario. The requests which are coming from the user and the kind of QoS requirement they have, they need to be analyzed, and then the resources based on the QoS requirements need to be allocated. So it does not provide a good performance in real environment. Examples are first in, first out, round robin, shortest job first. So first in, first out means whichever job comes first, it has to be executed first. Round robin, so that means every job will be executed in a round robin fashion. Shortest job first, whichever job requires the least amount of whichever is the shortest job requires the least amount of execution time, or will require a least amount of resources, will be catered to first. What is more applicable to cloud computing is dynamic scheduling. So in this, there is no need to have any advanced information about the resources required by the workload jobs. So in this, the algorithms are more efficient and accurate for cloud environment, because if a node is in overloaded condition, then tasks can be transferred from an overloaded node to an underloaded node. This is called load balancing. So load balancing can be done. So in this, the monitoring of the node has to be done continuously. So these are very easy to implement, but complexity is high. So these are few examples of dynamic scheduling. Many optimization techniques are there: particle swarm optimization and colony optimization, cluster based, dynamic round robin. But we'll not study these algorithms in detail in this particular course. Another term for scheduling is online and offline mode scheduling. So what happens in online scheduling mode? In this, the customer request is mapped with the running virtual machine when scheduler gets the request from the customer side. So each task is scheduled only once. The scheduling result will remain unchanged. So this is online. And the second one is offline. So what offline scheduling is also called as batch mode scheduling. So what happens in this is the application request is allocated to the resources based on the predefined moments. So it is used to calculate the processing time of larger number of tasks. So what happens is based on the history, previous history, the way the scheduling has been done, a particular task will be scheduled. So that is why it says based on predefined moments. And to do this, it has to the entire previous history has to be stored and analyzed. So it is used to calculate the processing time of large number of tasks. Then is a preemptive or non-preemptive scheduling. In preemptive scheduling, the task can be interrupted at the current execution and can be migrated to other resources. Whereas in non-preemptive, when a task is allocated to cloud resource, it will not be freed until the task is finished. That is, task is executed completely at the resource without being interrupted. So preemptive scheduling will be done for those cloud requests which are maybe not real time. But if a request is a real time service, then non-preemptive scheduling is definitely preferred. It also depends on the service level agreements, that whether the scheduling can be preemptive or non-preemptive. Let us look at what is resource monitoring. So we understand that once a workload comes, it has to be, the resources have to be provisioned for it, and then the workloads have to be scheduled on that particular resource so that they are executed in a minimum amount of time and without violating the service level agreements. However, while execution, it might be possible that it might be required that certain more resources are allocated to it, or it has been over provisioned and certain resources can be freed from that particular user demand. Performance optimization can be best achieved by an efficient monitoring of the utilization of computing resources. So in service level agreement, both parties, that is the cloud provider and the cloud user, they specify that if there is any possible deviation, then how many times that deviation can be there or how much deviation can be there. So this has to be specified in service level agreement. And this is important to achieve the appropriate quality attributes. So the resource monitoring system collects the resource usage by measuring through performance metrics such as CPU and memory utilization. Then the cloud provider needs to retain the adequate number of resources to deliver the continuous service to the cloud consumer during the peak load. So, and the resource monitoring is used to take care of the important requirements like QoS requirement, like security, availability, performance, etc. during the workload execution. So, once the workload comes and the provisioning and the scheduling are done, the task does not end there. During the execution also, the entire time resource monitoring is very important. Might be possible that certain more resources are required, or certain resources, or it has been over provisioned and certain resources can be returned back to the resource pool. So, but if the task requires more resources, or there is a certain peak in demand, then the cloud provider must have adequate or backup resources so that it can support the ongoing executions such that quality of service requirements are guaranteed, and the service level agreement is not violated. Though in SLA, both cloud provider and cloud user specify that how many times it can deviate from the. So if I say that it should give the availability should be this much of a particular service, then it might be possible that it is not available, maybe let's say for a couple of seconds or milliseconds. Then how many times such instances when the service is not available occurs? So this is called as deviation. So it should be specified, okay, this many times there can be disruption in the service, but beyond this it is not acceptable. So all this has to be mentioned in SLA. So basically, resource monitoring is very important so that SLA is not violated. The two main aspects of resource monitoring are: first, consumer wants to execute the workload at minimum cost and minimum time without violation of SLA, and provider wants to execute workload with minimum number of resources. And we know that these two are contradictory requirements. Resource monitoring is a vital part of resource management to measure SLA deviations, QoS requirements, and resource usage. So resource monitoring will ensure that SLA deviation is within bound, QoS requirements are being met, and the resource usage is optimum. Finally, let us look at quality of service based resource provisioning. Now, we know that the ultimate aim is that SLA should not be violated and the quality of service guarantees should be provided to the user. So, while doing service provisioning, if quality of service is taken into account, the workloads which are coming, if the quality of service is taken into account at that time when the resources are being provisioned, then it is called as QoS based resource provisioning. So what does it do? It says analyze the workload which are coming and categorize them based on the common patterns, and then provision the cloud workload before actual scheduling. So it says that whatever workloads which are coming, they can be analyzed. They can be clustered also based on a specific QoS requirement, and then the resources can be provisioned for them. So QoS metric based, so QoS metric, we'll just see what this QoS metric is. It says that QoS metric based resource provisioning technique is efficient in reducing execution time and execution cost. So if we look at this here, we have a workload resource manager. We also have a block here which is called workload analyzer. In this, there is a pattern based clustering block and a metric based clustering block. It has input from two other blocks. One is SLA measure, another is QoS metric. Rest, this is a resource provisioner, scheduler, resource pool, which is same as in resource description, which was same as the previous diagram. So let us try to understand this. What is SLA measure? So in this, the SLA measure studies and confirms the QoS constraints which the workload has. Based on this, the workload manager checks the availability of the resources. And this QoS metric will actually give a metric by comparing all the workloads, their QoS requirements. It gives a metric based on which the clustering of the workload is done. So basically what it says is, it says that the basic idea is that to cluster the workloads with similar kind of quality of service requirements and then do the provisioning of the resources for the given workload. So provisioning of appropriate resources will depend on QoS requirement of the cloud workload. So to sum up this lecture, in this lecture we have studied resource management, which broadly has two components: resource provisioning and resource scheduling. We saw what was the need of or what is the objective of resource provisioning, and what are the types of resource provisioning, We further also saw that what the types of resource scheduling. Then we went on to see what is resource monitoring, which is very essential. That is to continuously monitor the resources during the execution of the workload. And finally, we saw QoS-based resource provisioning and how it can, and it is known to reduce the execution time and execution cost. Thank you.